Hello, welcome to Hawk Math. Today we're going to be doing the following problem. The limit as n goes to infinity of the sum from I equals 1 to n of I divided by n to the nth power. Now, my first thought when I look at this problem is that I see this I over n to the nth power and a limit of a summation, and I immediately think this is some form of a Riemann sum that can be rewritten as an integral expression. But we actually can't really do this because this exponent n right here doesn't really allow us to rewrite this expression in a way that gives us a Riemann sum. So we need to look at other ways to do this problem. So let's write out the first few terms. So if we had, let's just say, I being 1, so we have 1 over n to the n plus 2 over n to the n plus 3 over n to the n, and so on, up until we have n minus 1 over n to the n plus we have n over n to the n, right? Now, let's look at what these terms really are. Well, if you notice, this is really 1 to the nth power, so it just becomes 1. And right here, this can be rewritten as 1 minus 1 over n. And the term before that, which I didn't write, can really be written, if the numerator was n minus 2 over n, then it would be 1 minus 2 over n, and so on. So we can actually rewrite this term. I'm going to flip the whole series backwards as 1 plus, we have 1 minus 2 over n to the nth power, starting here, 1 minus 1 over n to the nth power, plus 1 minus 2 over n to the nth power, plus 1 minus 3 over n to the nth power, and so on. And this is going to be rewriting, and we want the limit of this as n goes to infinity, right? Now, in order to solve this, we should be able to recognize this expression right here as e, because this is actually equal to e to the negative first power. I might do a video in the future on why this is so, but for now I'm just going to write out this property that the limit as n goes to infinity of 1 plus 1a over n to the bn is equal to e to the ab. So I might do a video on this in the future, but for now let's just take that as a given. So now this becomes 1 plus, this is e to the negative first power. This becomes e to the negative second power. This becomes e to the negative third power, and so on. Up until, if we look back here, we went all the way until 0, so this keeps going on infinitely until we get to 0. Well, this now is just a geometric series with the first term of 1, and so we know the sum of geometric series is a over 1 minus r, where a is the first term and r is the rate. So we have a, which is 1, over 1 minus the rate, where the rate is 1 over e. So rewriting this, we can multiply the numerator and denominator by e, and we get e over e minus 1. And we are done. Thank you for watching. I really hope you enjoyed this problem. Please like the video and subscribe if you want to see more like this.